This is a daily problem, where is a kind of uh, big description, but we just see each point, we can clearly understand that this problem is of medium. So let's just read the problem statement and try to understand what the constraints they are given and what need to figure it out. So in this problem statement, uh, you are a you are in the charge of a smart dam system where the dam will store water in sequence of n chambers. So it is like uphill to downhill. So you need to make the decisions like, uh, to flow the water from uphill to downhill. You need to make the proper decisions with these constraints. And for every chamber, there is a capacity and there is an initial units of water. So for each step, you need to do these things. So you need to transfer all available water from chamber I to I plus 1. That means from current chamber to next chamber. And during this transfer, so there is some natural loss. So that is due to some evaporation or some leakage. So we will be given a percentage of loss. So that percentage of loss will be lost in this transfer. So the remaining water after the loss will flow into the next chamber. Uh, if the water at chamber I plus 1 exceeds its capacity, then the excess water will overflow and it is permanently lost. So our goal is to determine the final amount of water retained in the last chamber after the flow reaches end. So this is a problem statement. So let's take this sample test case and try to understand the problem clearly. So the given test case, sample test case is uh, 100, 100, 100, like 0, 20. So this is the first test case they have given 100, 100. This is the capacity, and this is the initial water, and this is the loss percent. Okay, so n is given as 3. So n is 3, and they have given the capacity and initial water. So let's try to understand the problem. So it is clearly stating that, 1 minute. Let's imagine we have 3. three chambers like this. So we need to move the water from this 0 and this is 3. So 0th chamber to 3rd chamber like this. From 0 to 1 the water will flow, and from 1 to 2 like second chamber, and index is 3. So we need the water will flow like this. So during this process there is some loss of water due to evaporation. So the evaporation loss percentage is 20% in this case. So 20% means 20 divided by 100. It is equal to 0.2. So whatever the water comes from previous chamber, that water will be multiplied with this loss percent. That is, let's suppose in this case, uh, they have given 100, 100, 100. So for the initial capacity, the starting chamber capacity is the initial capacity. So the initial is equal to 100, right? 100 is the water, but in the initial capacity of chamber is 90. Then the first 0th chamber will store 90 water. So let we want to go to 1th chamber. So during this process there is some evaporation happens. So let's find out how much evaporation happened. So previously the water is 90 and loss percentage is 0.2. So 90 into 0.2, which is equal to 18, which is equal to 18. So this is the amount of loss. So we need to subtract from the total water. So 90 minus 18, which is equal to 72. So this much of water will flow into this, will store in this uh, second chamber. So 72. And one more thing is that here here the initial capacities are given, initial water. So in the first case there is 90, and in the second case there is 0, which is empty. So the amount of water which came from this chamber will entirely fit in this, because the capacity is 100 and the initial water is 0. So let's just move. So in the first chamber we will store 72 water, and we need to move to second chamber. So for this also we need to calculate mm, the loss percentage, and we need to remove the water from it. So let's move here. So from previous one, how much water did we get? So we got 72 water from 1th chamber, and we have loss percentage 0.2. So which is approximately equal to 14. So 14 is the loss of water. So we need to subtract from total that is received from first chamber, that is 72 minus 14, which is equal to 58. So that is the water will store in second chamber. So we need to return this amount of water which is present in n minus 1th chamber. So in this is the last chamber we have, right? So we have three chambers, 0, 1, 2. So in the last chamber is second chamber. So in this we have 58 amount of water. So this is the answer that we need to return. So we are following these constraints and doing the operation. So this is the example description of this problem, and let's code this up uh, in the approach that we have got, right? So the constraints are of 10 power 3 and capacity initial 10 power 6, loss percentage is 50. So let's do the code part of this. What do we need? We need n, right? So initial dot length, and we need to find the loss. So for that purpose, I will take double of loss is equal to loss percent divided by 100, point 0. So we need to keep point 0 to convert it into loss percent, right? Hello, Umar. Correct. I'm spelling your name correctly. So next one is need to take in previous is equal to the first state, right? So it is the minimum method at minimum of capacity of first and initial of first. Okay. After that, we'll start from 1 first chamber. So int I equal to 1. Mm, hello, hello, Harsh. So we need to find current. Current is equal to, I'm good, bro. Whatever you. So previous minus integer of math dot formula, bro, can you hear me? Math dot seal of hello, capacity of y. No, no, no. It will be previous, right? I'm good, bro. We need to take previous into loss. So that is what they're asking, and we have to add this uh, initial. How have it? Now you need to check this if it is overflow or not. So in that case, the maximum capacity only we can take. So for that purpose, let's take curve is equal to math dot min of curve comma capacity of y. Then reduce my previous minus. Okay, okay, completed. Mm, It wasn't previous is equal to car and just written previous. Mm, I think it's done. Let's try to compile. So possibly test cases. Let's try to submit. So it don't give correct answer. So this is the approach that we need to follow for this problem. So thank you.